Okay, howdy everyone. Last major lecture topic, well, major subtopic in topic one, the intro to human factors and ergonomics. And this is collecting task data. So this goes very closely with the previous lecture 1.3 that introduced analysis and design methods. This, in a general sense, 1.3 did, the overall process. These are a little more like, hey, here's a method, that you could, now that you will have learned it, could go out and apply. So collecting task data, and what I mean by task is very commonly we're analyzing how a human performs a task. So I'm using the nomenclature, that the textbook uses. Not exactly the same as our systems oriented sorts of things, but I hope you can, if we focus in on the task aspects of our defined system, like we talked about in 1.3, we can really dig in deep. We can do things like, like the Gilbreths in terms of looking at units of work, that are performed in a task, physical or cognitive steps. So, one of the most obvious, easiest access, especially for students, is a review of what is been done before, related to a certain problem or a certain way that tasks are performed. So literature review is always a part of any research endeavor. And I have this one, basics of anesthesia here, because when I was a PhD student, I was working with anesthesiologists. And so, well, how do you perform these various tasks? Where does your attention go, with these various monitors and things? And so I actually read a textbook on anesthesia, and I felt like, oh, I could, if this PhD thing doesn't work out, I can become an anesthesiologist. So, but in any case, this is part of the review. I want to learn how people do things, how they're supposed to do things. And so I've got, training manuals, textbooks, equipment manuals. Of course, the internet is a great source of all of these things, and I won't have to, I hope, tell people that Wikipedia is only as good as the last person who edited it. It will never be acceptable to cite Wikipedia as a scientific source for this class, but great place to go to gain access to or find reliable scientific sources, and to get an overview of what they're stating. But don't cite Wikipedia. You can go to the citations at the end of the Wikipedia article, find those sources yourself, verify that they make your point, and then you can cite those. All right, so yeah, we're going to do our background search. We're going to look for how do people do these things. All right, next, observation. Now this sounds very much like a, hey, go and watch people, but I want you to think of this as, no, this is a formal method. It's got predefined sorts of ways that you would go about this. There is a real skill to observing how people do something without affecting how they do something. I forget what is it, Heisenberg or something. Yeah, you can't simultaneously discover how people act in the natural setting and not impact them. So there are ways to, basically the encouragement is don't interfere with their task in any way, get a sense for when it's okay to ask questions, to get elaborated things, take notes and follow up retrospectively. And be prepared if you're going to go and do a data collection, right? So I did this with anesthesiologists. I spent weeks just observing, anesthesiologists during surgeries. And if, I hadn't done that, I wouldn't get at a lot of the deep understanding that I have. I wouldn't have gotten that just from the textbooks, right? So, and this allows me, before, I knew beforehand going in, I wanted to look at specific aspects of how the various displays worked, what the anesthesiologists were thinking about when they were gaining information from the displays, when they were reading them or listening to them. And then, look at, well, how do different operators go about these tasks differently? Different anesthesiologists, different, anybody who is performing the task. And this is informative because it shows, well, there's kind of one standard way to do it, or there's a lot of different ways to do it. for good and for bad. It may not be a negative thing, but it helps you understand more completely how people are attempting to perform these tasks in their current systems. Really great to have multiple perspectives on this. So when I've done work in hospital settings, it's very commonly a 24-hour thing. So we'll look at stuff like, well, what happens in the middle of the night? So not with anesthesiologists anymore, but more like, cardiac units. We did some work with this, and we had 24 hours to cover and 4 scientists, well, 2 faculty and 2 students. And so we made the students be the ones in the middle of the night for the most part. But we had, a couple people each time with different perspectives, basically kind of trying to look at different aspects of the work. Long observation periods, you're going to get more natural sorts of interactions. The easier it is for the workers to forget that you are there, you, the human factors data collector, are there. If they forget you're there, they're going to act more naturally. They're not likely to forget you're there in the first 5 minutes you're there. So longer periods does help people to get more into their natural rhythms. Several observation periods, like during the day when it's nice, and in the middle of the night when it is the middle of the night. Sometimes that's very necessary. You're going to identify, particular problems that may have to do with different times of the day or different times of the year. In the hospital setting, again, there are periods of time where, well, let's look at it right now, after the holidays. And so now all of the ICUs in the world are overrun by COVID patients. for anybody who is, cultures that celebrate holidays around this time of, around this, end of December. All right, so you want normal and non-normal conditions, because the normal ones are the ones you normally have to support. But non-normal conditions, like when everything goes wrong, are incredibly interesting and important to study as well. And I'll talk about why, but it makes obvious sense. This is when trouble happens. This is when things can most likely go wrong. They're also the most memorable because they're unique, non-normal conditions. So I'll talk more about that in a bit. All right. So one of the ways, so this, I mentioned there are these formal sorts of ways to go about these interactions in the natural workplace, for example. One we call contextual inquiry. So this is the method name, but the essence of it is the scientist, the human factors data collector, basically adopts this role of an apprentice. And you're not fooling anybody, but if you go to the worker and say, I want you to imagine that you're the master of doing this task and I am the apprentice, and you're going to teach me everything that you know about doing this task. And what that, when it's more of a teaching sort of thing, this is when people will naturally think about, well, I need to tell them to do this and why they need to do that, what I'm thinking about when I do that. So the same way you're showing somebody how to do a new task for the first time and you care about them, as like a master apprentice sort of thing, like Daniel-san and Mr. Miyagi here. So it just helps kind of open that conversation to be much more informative, not just what they're doing, but why they're doing certain things. Okay, so I mentioned, sometimes you can't interrupt people without really messing up their task. And I'll give a great example of, I mentioned in the previous lecture about some of my research with weather apps and weather displays for cockpit, for general aviation pilots in the cockpit. It was really hard to say, hey, here, when everything is going wrong, even in a simulator, when everything is going wrong weather-wise, use this app and tell me what you're doing. Tell me what you're doing and why. Now, you can imagine why that could impact things, but then there's several different ways we can get insight into what's going on. So if we ask people to explain what they're doing, to almost verbalize their thoughts, so almost like it's really hard to do. It usually takes some practice. Every time I've done this, we've needed to train participants so they know what we want of them. And even then, rarely did you get a really good think aloud protocoler. So, to be able to just run your mouth and to continuously output what your brain is doing is a challenge. But that's the general idea. So here's one of the better ones. I hope I did it right where I'm sharing the sound. But these are our videos. You'll notice I've blurred everything out. That's because when we do these studies, we're always protecting the identity of the participants. That's a fundamental thing about the research we do. So I also modified the voice so you couldn't tell who it is. But this is a pilot, and they are interacting with a weather app that we made a prototype while they're in a simulated environment. So you can listen to the sorts of verbalizations that we were encouraging and wanting to hear.
Let's see what Skagway is.
Skagway is
we got a pirate visibility at.
It's an airport in Alaska.
8 statute miles, 5,000 feet. We're in good shape at Skagway. If I can just fly the airplane.
This was a key demonstrated point. If I could just fly the airplane.
We
were showing the distraction potential of some of these.
Pirate visibility. Let's see where we are.
I think it's repeating now. Oh, no, here we go.
We're still good there. So we will continue to Skagway.
All right. So again, that's a video clip example of the Think Aloud verbal protocol method. This is a participant. We had to train them to basically tell us what they're thinking. Don't just press buttons. Tell us why you're pressing those buttons, what you're thinking about that is going through your head when you're making decisions, related to what you're doing. All right. So as I mentioned, these protocols can be really tricky, especially if you're basically telling somebody to do the task you want them to do and then talk the whole time, and that's going to disrupt the natural flow of that task. So that's a potential problem. Another issue, which I talk about in 631 quite a bit, with the way that humans process data under different modes of operation, performance modes. Some things we do become so well practiced that they're almost automatic, and to the point that we don't even really have conscious access to what we're doing exactly. So this bike rider here, who I can assume is an expert bike rider and has been doing this for many, many years, if you ask him to give you a Think Aloud protocol on what he's doing on his bike, he'll just be like, well, what do you mean? I'm just riding my bike that way. And not the same way that maybe a toddler would need to hear, like you need to push with your leg and coast and push with the other leg, and this is the brake. And it's much more direct and conscious and rule based. So this becomes an issue when you have somebody who's really, really good at something. They've been doing it for so long, they're really well practiced with it. And now you ask them to verbally describe what they're doing, but it's so automatic for them, they literally don't have the words to describe it to somebody who isn't living in their own brain. Okay, so that's a potential issue as well. Now, and one thing I didn't put here is, Think Aloud verbal protocols can be done retrospectively. In fact, that's some of the work I'm doing with the Army right now. That's what we're doing. So we're videotaping people while they're doing it, capturing as much as we can of that context, not interrupting them. And then later on, we show them the video and the audio, and we say, hey, I want you to relive this moment and tell us what you're thinking and tell us what's challenging you. So we can get at that without disrupting the task. You just have to rely on people's memory, and that will, of course, fade with time. And if you take them out of the heat of the moment, it won't be exactly the same. Okay. Interviews. So this isn't me observing somebody. This isn't me being an apprentice master thing. This is me coming in with a set of questions that I want to ask, maybe want to ask multiple people. So we can have structured or unstructured interviews. Structured interviews would be, here's my list of questions. Unstructured interviews might be more like, I want to go and ask you questions about this particular task and how it affects you in these conditions. So it could be a lot more general, and let's explore where this conversation might go. All right. A focus group is basically an interview with multiple people all present at the same time. Can be very effective for getting the opinions of multiple people while only having to ask the questions once. So you know it's more efficient. The downside of this, as some of you might see here, is this idea of groupthink. And that being a limitation of in the sense of if one person has X ideas and the next person has Y ideas, the combined sum of their ideas is not X plus Y, it's less than that, because people tend to kind of follow along where the group is going with these conversations. So if you had people individually, you'd get a greater quantity of input. Having them together, you're losing some of that, but it is more efficient, cost effective as well. Okay. Sometimes you don't have a chance to interact with people either, you know, in person or, you know, over the phone or Zoom or whatever, and you got to just send them, hey, answer these questions please on your own time when you're able. So we've all done surveys and questionnaires for various reasons. I have done them as a researcher. You know, I've done formal surveys that went out via the internet to, you know, thousands of people, and when they responded, we paid them and everything. I've done that, and I've done with almost every study we do in a real context, like in the hospital or with the Army. We're asking a number of questions about the people's experience, the subjective experience. So, you know, it's sheets and sheets and sheets, and what are you going to get out of it, and whether the questions on those sheets. So if you can imagine, hey, fill this out and get it back to me, I don't have as many opportunities to say, well, hey, what did you mean by this? Can you elaborate on it? I don't get another chance for that. So I have to ask the questions in a very particular, careful way. And whether I leave the questions open-ended, like, hey, tell me about how you experienced workload while doing this, then just, you know, fill the box. That's going to be a little harder to take 1,000 people's worth of responses and combine them in a way that you can summarize. It's going to be more like you're going to have 1,000 different responses, which can still be useful, but it's harder to, you know, it's harder to put things together and summarize them. If they're closed, then you can say, you know, answer on a scale of 1 to 5, for example, how much workload doing this, you know, gave you. Well, now you can have 1,000 different numbers. Now you can do things like statistical analyses, but you don't get a chance to see, well, what are the reasons behind that? So the way you ask the question, you know, you're going to get more or less information that's easier or harder to combine into a summative sort of understanding. Yep. Collecting quantitative data, good to have a closed one, so you have just, there's only these numbers you can give me. Okay. Oh boy, the critical incident technique. So, you know, worst episode ever guy. That's all I wanted out of this. It's a whole animation here. But that's kind of the idea behind this technique. So the critical incident technique assumes, well, it's a pretty good assumption, but every single person has had either the worst day ever on the job, or maybe the best day ever on the job, or maybe both. And those two types, those two extremes are unusually important, because everything goes right and you can learn about why everything goes right, or everything goes wrong and you can identify, you know, you can analyze the reasons around that. Either one's going to give you quite a bit of valuable information for how systems work. The other good news is the best day and the worst day are much more memorable than the average day. So if you ask somebody, hey, tell me about your workload doing this task on an average day, versus tell me about it that one time when it was 50 degrees below zero and you were, you know, and it was rainy and nothing was working right, and then what, you know, and so then people will be able to elaborate. So it doesn't necessarily need to be a negative event, just to remember that. So critical incident sounds negative, and it usually is, but it doesn't need to be. It's really just more about an extreme event. And they're not always rare, I guess. So extreme I don't know how I can rectify that. So they're generally memorable because of their rareness, but they don't always have to be rare. Let's put it that way. That's a funny picture to put next to. It's not always rare. This happens all the time. Okay. Sorry for the disruption here. My microphone battery ran out, and so I'm re-recording just the last two slides here. But as I was saying before the thing ran out, another great source for a good starting point, along with the lit review and looking for information about the task or whatever the domain is online. You can also look and see where were the biggest problems, and some fields do a much better job than others at keeping records of when things go wrong. So the difference, let me start with the header there: incident versus accident. An accident means something bad happened. An incident maybe means something bad almost happened. Okay, so an incident's usually not accompanying with a loss of life. You can also call it a near miss. So very interesting, very relevant, because it's where some things started to go wrong, but it's not, just the best kind of accident is one that doesn't harm anybody, I guess. So aviation is one of these that's really fantastic for reporting when things go wrong. There's a culture of reporting that's really supported, facilitated by the community. And it's better for everybody. So you can imagine, though, it's kind of hard to say, oh, I screwed up. I'm a pilot. Oh, I screwed up. I almost crashed doing this stupid thing. But that culture does very much report that kind of thing and take it very seriously, because then somebody else could learn and say, oh, I kind of do that too, or I thought of it that way also, and I could have found myself in similar trouble. Also, part of that is this domain is not punitive. Okay, so it's not going to punish a pilot for reporting if they did something wrong. I mean, to an extent. However, you can imagine there are other domains, medical domains in particular. Remember how high those preventable medical error rates are, where it's really hard to say, oops, I'm a doctor or I'm a nurse and I made a mistake that maybe hurt the patient, because now I'm liable. So why would I volunteer that, without getting my arm twisted? So generally, there are databases for when things go wrong, but how broadly they're shared really depends on the domain. So ASRS, the NASA Aviation Safety Reporting System, this is really what I was talking about. We can go to this right now. Let's do it. We can go right to the ASRS, and we could look up NASA ASRS. We could look up weather-related accidents. So, and this is available, for anybody who's curious. How often, do accidents involve weather? Yeah, if it's going to load, I'm probably not going to do it. But just know that that's a public resource that you could use for research purposes, and I have used for research purposes. As I mentioned, the medical domain, much harder to get, clear descriptions of when things go wrong because of the liability. But the Australian Incident Monitoring Study, AIMS, was one that was really influential and useful for me when I was learning about, when things can go wrong in anesthesia. So again, there's issues with, punitive punishments if you admit to wrong. So again, this is, kind of domain by domain. All right. Well, that's the end. That's the end of this topic. Thank you very much.